Hello and welcome to our session as part of the Things Virtual Conference. My name is Marius Winzler, and together with my colleague Markus, we will introduce you to the necessity of regulatory approvals for devices using radio technologies, such as LoRa WAN.
Hello and good evening, or maybe good morning, good night, wherever you are in the world. Also from my side, my name is Markus, being Managing Director of CETECOM. And yeah, as my colleague Marius Winzler already introduced, we're going to talk about regulatory approval for radio devices, respectively for LoRa devices.
Okay. And when we are looking at our session today, let's have a look at the agenda of our presentation. After a short introduction, we will cover the current regulatory environment in Europe, including the requirements for radio EMC and safety testing. After that, we are going to have a look at the requirements for the market access to the North American market, respective the US and Canada.
In the end, we will present you also with a link where you could issue your questions arising during our presentation. And so everyone gets a chance to also ask about what you're going to see today. Okay, let's give it a head start.
Okay. So I'll cover the introduction and would like to start with a general view on the topic of regulatory approval. So in general, it needs to be said that any party or any manufacturer wishing to put products on the market within the EU must prepare a DOC. So basically the DOC is the conformity assessment, and depending on the product, the applicable procedure really depends on the relevant directive and the related risk potential posed or related to the product. The manufacturer or the representative base within the EC declare that the product which needs to be marketed corresponds to all the relevant safety and health requirements, which are related in Article 3.1 of the Radio Equipment Directive. So in a nutshell, devices without radio interface need to be conformed to the Electromagnetic Compatibility Directive, so the EMCD, which is then related to the relevant EMC testing. Devices with radio interfaces need to be conformed to the just mentioned Radio Equipment Directive, so the RED, which provides all the relevant information for the related radio testing. Devices with more than 50 volt supply voltage or radio interface need to be conformed to the Low Voltage Directive, which is then related to the safety testing. When we now have a closer look at the basic requirements stated under Article 3.2 in the Radio Equipment Directive, it is important to mention that radio systems need to be designed in a way that the radio frequencies are used in an effective way, as well as they are supporting an efficient use of the radio frequencies in order to prevent any kind of radio interference. Two notes here, which are important to understand the whole concept. We would like to start with the effectiveness. So looking into the measurement of effectiveness, for example, the ratio of the achieved goal to the defined goal, it is important to understand that this is related to doing the right things. When we look at the efficiency, which is a measure for the energy expenditure, so for example, the cost-benefit ratio or the rational handling of rare resources, this is related to doing things right. When we close the link to radio equipment, it is important that the equipment really supports certain features to protect against fraud. The radio equipment really needs to support certain functions that ensure the access to rescue services. It is important that the radio equipment device supports certain features that are really designed to facilitate their use by people with disabilities. And last but not least, it needs to support certain functions to ensure that only that software can be loaded which have demonstrated the conformity of their combination within the radio system. That really relates to the comparison of hardware and software versions which are named in the conformity, etc., etc. That brings us to Article 3.3 within the Radio Equipment Directive. Here it is stated that the radio systems need to be designed in certain categories or classes to really meet the essential requirements, which are the compatibility with accessoires, in particular with uniform charging devices. The radio equipment needs to work together with other radio equipment via networks. The radio equipment can be interconnected across unions via interfaces of a suitable type. They shall have no adverse effect on the network or its operation, nor will it really result in a misuse of network resources. And again, last but not least, the radio equipment has a security factor that ensures that the personal data and the privacy of the user and the subscriber are really protected. When we then look at the next topic, a particular thing we wanted to cover is really what about starter kits or devices at trade shows, because that's something which is really important in the environment of the Things Network, and that's the thing where I would like to hand over to my colleague Markus.
So this chapter really arises from questions we got from our customers, or maybe also from fairs that we attended as exhibitor, where people asked us, okay, I have designed the device is not yet CE conform tested, we did not do regulatory approval for that device, how to handle this device on a fair. So according to chapter 2.3 of the so-called Blue Guide, the Blue Guide is issued by the REDCA, the Radio Equipment Directive Association. Placing on the market is considered not to take place where product is displayed or operated under controlled conditions at trade fairs, exhibitions, or demonstrations. It is also to be found in Article 9.2 of the RED, which, as a summary, says a visible sign clearly indicates that such radio equipment may not be made available on the market or put into service until it has been brought into conformity with this directive. Meaning, if you put a device on your desk at a trade fair, you need to show that this product, as of today, the day you're showing the product, has not been tested according to regulations, according to the necessary standards. Demonstration of radio equipment may only take place provided that adequate measures as prescribed by member states have been taken to avoid harmful interference. Meaning, if you operate your device during the fair, you need to make sure that you are not going to harm anybody. Harming means in terms of health, so it could be touch, people could come near to the device, and you're also not causing any interference. Best example would be you, for example, have a starter kit that is being designed to be operated in short-range device band USA, which is 915 megahertz, for example, and you're operating this in Germany. 915 megahertz in Germany is GSM 900 band, and then you're crisscrossing with the operators like, don't know, German Telekom, Vodafone, Telefonica, don't know, who have their licenses in their band. So you need to make sure that whatever you're operating, you're not interfering. If the radio equipment contains a transmitter, the relevant national spectrum authorities have to be contacted. So here it's black on white. You're not going to, let's say, operate in bands that are licensed. If during the development and production of a given radio equipment, samples or pre-production units of that equipment need to be operated in normal use locations for testing or validation purposes, so-called field tests, then the relevant national spectrum authority has also to be contacted. We know that from mobile communication industry that mobiles are being tested in so-called field trials, and of course, if you operate these, please contact local authorities. So anyway, the Radio Equipment Directive introduces also an exemption for custom-built evaluation kits. This is despite any usage or demonstration on a fair. It says that custom-built evaluation kits designed for professionals and to be only used at research and development facilities are, for example, allowed. The problem is that this kit and the number of people that uses this kit needs to be documented somewhere. So, for example, you have a design kit that has been used at a research facility, and there are many, let's say, companies, institutions involved in that research project. Then everyone using such kind of kit needs to be listed somewhere. So, if you're checked by the local authorities, you need to present this list, who works with that kit and in what kind of projects. The research character of this needs to be quite clear. The unique design and characteristics of the kit makes it solely suitable for that research and development project. This kit is not to be marketed, so it is not to be sold to the, let's say, outer world. If that evaluation kit is later on provided on a regular basis, or once the kit is not used for that joint research project any longer, it can no longer be considered as a custom-built evaluation kit. So in general, the definition is a kit, a custom-built kit that is no longer with a single customer, but with more than one, is no longer custom-built. It's two customers, whatever. This is from definition point of view. So evaluation kits, according to RAD, can be run without regulatory approval, without CE mark, as long as it sticks to development facilities, bracket, public or private research and development bodies, or designed for professionals and to be used solely at research and development facilities. As I said, it needs to be clearly stated that this is only for development purpose. It's not to be used like, okay, I'm a manufacturer of a microcontroller, for example. I put it on a starter kit and I hand this starter kit to, let's say, all my customers. And this is not research and development. Next. Non-exhaustive list of examples of evaluation kits that do not benefit from this exemption, even if there is a possibility for the user to adapt this to his specific needs or to build it himself. All devices and equipment used on regular basis, so it's not once, it's regular base, to perform tests for the purposes of research and development or for other applications, such as to demonstrate the conformity or quality of a product. Evaluation equipment for users in general in research and development departments. Equipment is always the same and it is not custom built. So this should give you an impression that the exemptions being raised in the RED are not that easily to be fulfilled. So we got many requests from customers saying, yeah, okay, it's just for development purposes. We can declare it a research project. Why not having it in a web shop, selling it, and let's sign from every customer a document indicating this is a research project. Then I spare the regulatory approval. Okay, this is very complicated and you take such a high risk for such the regulatory approval process. We definitely recommend, if you sell a kit into the market, to do regulatory approval. We definitely do not recommend to put it on a research basis. the requirements to get accepted as a research project for such a kit are quite heavy. Okay, with this point, I would like to hand over to my colleague Marius Winzler again.
So what we are doing right now is that after the introduction, we are going to have the view or an input on the regulatory view on the LoRa radio technology. And first and foremost, as just introduced, we are looking at the Radio Equipment Directive because the so-called RED defines and regulates the basic framework of placing devices with radio technology on the EU market. The RED is really inhibiting the ETSI standards as well as the EMCD and the LVD standards. Looking into the ETSI standards, they're basically defined by the European Telecommunication Standards Institute, which is an independent standardization organization for the telecommunication industry, and really defines the ETSI standards and specify therefore the detailed technical parameters, the limits, and the test methods for product compliance testing. In comparison, the ERC, so the European Radio Communications Committee, they are outlining recommendations, and for this particular example, so the LoRa radio technology, the REC 7003 defines the technical parameters and fields of applications for short-range devices. The reason why we're looking at this is, as you can see on this map, there is no such thing as a global regulatory approval. Many countries are using their own national certification schemes for market approval, but some really rely on the requirements given by the just mentioned Radio Equipment Directive or the FCC certification for the North American market. Therefore, it is always a good approach to start with the regulatory market approval for the EU as well as the approval for the US market, because that is a good baseline to roll out your product globally, because most of the countries really rely on certain aspects of the guidelines rolled out in the Radio Equipment Directive. In the next couple of slides, we would like to have a deep dive into the regulatory view on LoRa devices or the LoRa technology, and therefore I would like to hand over to Markus again.
Yeah, as Marius just indicated, regulatory approval is not the same looking on a global basis. The slide here shows which countries are, let's say, ETSI affected. You can see that Europe especially is green colored here. The European countries, small exemptions possible, are all ETSI members. Countries like USA, Canada, Brazil, South Africa, India, Australia, and also China are associate members. This means that these countries at least look onto what ETSI is doing and, yeah, let's say somehow also participate and somehow also adopt to the ETSI regulations. This does not mean if you have an European regulatory approval for your device that you can also pass the testing in the light green colored here. But it means at least these people have an understanding of the ETSI testing. Getting back to the LoRa devices, we're talking about 868 megahertz, 868 megahertz for the European short-range device band, the European ISM, Industrial Scientific Medical Band, which is 915 megahertz in the USA, which is 923 megahertz in parts of Asia. List not to be completed. You can see here different standards pointing out at different frequencies being of interest. This is 1356 megahertz. This is mainly RFID. This is 433 megahertz. This is also a short-range device band in Europe. We see the 2.4 gigahertz here, which is mainly Wi-Fi, Bluetooth, Zigbee, and all communication that runs on 2.4 gigahertz. And we see the 5 gigahertz frequency band that is mainly 5 gigahertz Wi-Fi, WLAN. Next. To make sure you're going to test according to the latest standards, we need harmonized standards, first of all. What does it mean, a harmonized standard? As Marius introduced, the radio standards for the European Union are developed by the ETSI organization. They develop standards that shall cover the requirements from the Radio Equipment Directive. Whether they cover these requirements from the Radio Equipment Directive or not is to be, let's say, approved by the European Union. If they do so, and the version of a standard is being checked and approved in the end, this standard is being published in the official journal of the EU, being said as, this is a harmonized standard. Whenever harmonized standards for a product are used, you do not need a notified body for your regulatory approval. If you stick to non-harmonized standards, so it is not checked that this version of a standard covers the requirements of a directive, you need a notified body. Let's come to this later. How do you find out about the latest standard versions that are available? First, you get to the European Union. This is the link in the very left part of this foil. Or you can see whether there are new standards under preparation. This could be seen on the portal.etsi.org link. Both links are available in the presentation. You may get afterwards. We're talking about the ETSI EN 300-220-2 here for the short-range device, also including LoRa devices. Going through this standard, you could see that there are mainly 18 different tests. So just naming some, it's operating frequency, unwanted emissions in the spurious domain, TX effective power, TX duty cycle, and so on and so on. New since the change from the RNTTE directive to Radio Equipment Directive, for example, is point 17, which is RX blocking. RX blocking means receiver blocking. This test is integrated here to make sure that the device only receives on the designated frequency and not, let's say, some steps beside this frequency. From environmental point of view, we have more and more radio devices coming into the market, and it would be fatal if your device, let's be it a temperature sensor, receives the temperature, let's say, from the neighbor's fridge. So you already have, let's say, 6 degrees Celsius outside, and maybe you have your heater in your flat being connected to that device, and your heater will permanently heat, and outside it's 30 degrees Celsius, and maybe this is a mismatch. So this is just a small example why receiver blocking is really important. Coming to a LoRa device, we can, let's say, concentrate on some minor test cases. This is 1 to 8, and the already discussed RX blocking. Like point 12, TX FHSS is just for frequency hoppers. If you're saying, okay, we're talking about a LoRa device does hop. So usually in a LoRa WAN device, we have at least 3 channels being activated per standard. This is not a frequency hopper in the eyes of the ETSI. If ETSI is talking about a frequency hopper, then they are talking about a device that hops 40 consecutive hops in a row and has a fixed defined pattern behind this. And any LoRa device, LoRa WAN device, does not have a fixed defined pattern. It could happen that a device transmits 2 times on one channel, then hops to the next. Could be then it's the first channel, then the third. there's no fixed pattern in behind. And this is why this is not a frequency hopper in the eyes of the ETSI, and this is, for example, why 0.12 must not be tested for LoRa equipment. So coming out in the end, we have those 9 tests. Operating frequency, yeah, of course, we want to make sure that the device transmits at 868 and not at 915 in the European Union, or yeah, it would be the other way around for the US testing, but during this presentation, we're concentrating on the testing for the European Union here. Unwanted emissions in the spurious domain, this means, okay, it really only transmits in 868 megahertz and does not have side lobes here, side interferences. TX affected radiated power, you may know that short-range devices in that frequency band are allowed to emit at 14 dBm, which means 25 milliwatts at a max. Power spectral density is an issue. TX duty cycle is quite important. According to the ETSI 300-220-2, we have a duty cycle allowance of 1%. 1%, this means 36 seconds on airtime per hour per channel. So LoRa devices are not designed to have like continuous wave transmission. This is not allowed. We're talking about an unlicensed band here. Unlicensed means everyone can use this 868 megahertz. And this regulation with the 1% duty cycle takes care that this channel is not being flooded by any kind of transmission. We would like to concentrate on unwanted emissions in spurious domain first. What you can see here are snippets from the standard, and you can see in detail what I mean. The diagram on the very left side of the foil shows a picture of, let's say, given limits, and these given limits have in the very middle the operating channel, the operation frequency, and we have the so-called out-of-band domain. You can see that there's a drop, I think it's about 3 dB drop here, to the side lobes, and it's made to be made sure that the transmit power and the transmit amplitude fits into this limit scheme. This has been tested here for the TX mode. Yeah, I think this is more or less clear once looking into very detailed limit scheme here. Coming into a real signal, we put here the signal with the center frequency of, I would say it's 8685 something. You could see a transmit bandwidth. In that case, it's 125 kilohertz, and you can see the 3 dB decreasement here per frequency step. So this signal here would be quite okay. Regulatory approval in this kind would be okay. Coming into the spectral domain, where this would also be checked, one could see the harmonics. Harmonics means if we're transmitting at 868 megahertz, we will also see frequency in 1.7 gigahertz, 2.6 gigahertz, 4.3 gigahertz, and 5.2 gigahertz. The ones here are been equipped with markers from a spectrum analyzer, so they are not numbered sequentially, but they are numbered in terms of their amplitude. So marker 1 gives the first harmonic at 1.3 megahertz, marker 2 gives the second, but the fourth harmonic, the third harmonic is being numbered 4 here. Anyway, all those harmonics have to be below a certain limit. In this case, it's 30 dBm, and this is a conducted measurement. All those peaks here are being tested in detail afterwards. This could be seen here. This is the first harmonic being tested in more detail, having a better resolution. And you could see that this is quite close to the limit of minus 30 dBm. So the marker points out it's minus 29.76 dBm. This is very close to the limit and needs examination. So usually we would not recommend to a customer, even if this is passed by 0.24 dBm, which is very, very small figure, to concentrate on the first harmonic. This is a question of design of the device, and this definitely would need rework. Yeah. Okay, so this is what the standard says in detail, especially also for the radiated measurements. We're still in the unwanted emissions in the spurious domain. You can see on the very right side, test facility for that one. Yeah, I don't think it makes sense to get in too much detail here, but in general, you could see that the device is being put on some positioner. We have a measurement antenna in the very back of the measurement chamber, and we could rotate the device in several directions. So usually it's quite uncommon to find a device that is really an omnidirectional sender, an omnidirectional transmitter. So usually, especially if we have harsh implementation, which means the device comes into a device that was not radio equipped before, but it was conducted controlled, then usually it's not the best place possible for a device for radio module inside the former conducted device. And with that, you will not see, like, don't know if someone of you has ever seen this dipole donut antenna diagram, which is quite ideal and which will not be, usually not be there in real life. Anyway, this is also just to give you an impression about what is tested, not going into too much detail here. Yeah, here also showing unwanted emissions in the spurious domain. You can see in the lower left side a picture of our semi-anechoic chamber, where we also do some testing here. In the middle, respectively, on the right side, you can see also limit lines and real emissions from devices. You could see, for example, on the upper right side, TX spurious vertical, that we're especially in the frequency range of, don't know what is it, 900 megahertz? Yes, 900 something. So there's really emission over there. Luckily, the limit is a bit higher over there. Otherwise, we would have an issue. So also just to give an overview. Next, we would like to come to duty cycle and TX ERP spectral density, respectively TX effective radiated power. The example taken here is from the Netherlands, and it shows the national authorities. In Germany, we have the so-called Bundesnetzagentur. This authority is responsible for checking that your radio device behaves like it was tested, past tested according to regulatory standards. What your regulatory, your local authority is and where they are based and how to contact them, you could find on the link on the lower right side. These people check that, for example, short-range devices only have this 1% duty cycle on airtime. They check that no one is amplifying a short-range device, for example, to increase the range. We all know that standard LoRa devices at 868 megahertz are able to transmit line of sight between 15 and 18 kilometers. So one could have the idea to extend the range to get an amplifier to the short-range device, not having 14 dBm, but for example 24 dBm, which is a significant increase of output power, resulting in much more range. But on the other hand, you're somehow spoiling you have too much signal on the unlicensed band for 868 megahertz here. It's not allowed, and it's also not allowed to have more than 1% duty cycle. This is just to show you that the local authorities really care for what you're doing with your device. With my former employer, we had test licenses in the laboratory. We have been able to also develop products for the US, for Canada, for Australia, and for other frequency regimes in the world. And therefore, we've been allowed to also transmit on, let's say, foreign frequencies. So that lab was also based in Germany, and we've been allowed to transmit, for example, on the US frequencies. The power there was reduced, and honestly, we have the German Bundesnetzagentur right in front of our building, let's say, every 2 weeks, and they've been checking whether we're behaving right or not. So please take care. And the details can also be found in the standard. By the way, I think I didn't mention that all ETSI standards are able to, that you are able to download them free of charge from the ETSI homepage. This is also portal.etsi.org. And you can get right into the standard and see the requirements, the regulatory requirements. For example, we have here band L, which we're talking about for the LoRa devices, which is 25 milliwatts ERP, equivalent radiated power. This is equal to 14 dBm, and we have a duty cycle or polite spectrum access, meaning listen before talk or something else, below 1% per channel. All others I would recommend to read by yourself. Sometimes those bands you can see here in the very end can only be used for video applications limited to 300 kilohertz and so on and so on and so on. Okay. This picture shows a duty cycle measurement. Luckily, I was allowed to take this picture here. This one is just a measurement of an 868 device showing a duty cycle of about 10%. So if this is a consecutive measurement here and the device continues to transmit a 10% duty cycle, that one would not pass regulatory approval testing. Necessary software. When people come to CETECOM and want their device to be regulatory tested, they're asking, okay, what kind of software do I need? Do I need special kind of software? Luckily, they are asking, as the answer would be yes. For any EMC testing, we would have standard application software. Standard application software would mean, okay, if you have a temperature sensor for your LoRa device, this temperature sensor measures and sends the temperature wherever. If we're talking about radio testing, this is a bit more complex. We need several kinds of softwares from you. For example, for TX mode, we would need continuous transmission or transmission on high duty cycle software. This is especially necessary if we're doing OTA testing, if we're determining the EIRP, equivalent isotropic radiated power. If we need to wait every 10 minutes to get to the next step, this measurement takes quite long. So OTA testing has been done with 1,440 steps in the OTA chamber. 1,440 steps with a continuous wave emission takes 20 minutes. If we're talking about a device that sends every 10 minutes one single signal that I could capture, then I have 10 minutes times 1,440 positions. No one wants to pay for that. So we definitely recommend to make up your mind before coming into testing. We could recommend what we need from you for most efficient testing, which is also, let's say, a price-sensitive testing. We need all kinds of modulation. If we're talking about LoRa, it's usually GFSK, FLRC, LoRa 125, 250, and 500. So you need to show compliance in all possible modes. So we need to be able to switch between those. Continuous wave, I said this in the first point already, is very important. We would like to manually select frequency and channel and transmit power if applicable. Standard LoRa software switches between 3 different channels. This is very, let's say, unlucky for testing and regulatory approval. We usually wish devices transmitting at a single frequency. If you have hopping activated, I had this X course regarding hopping. Please deactivate hopping for the radio testing software. For receive mode, we would need continuous receiving on a selected channel. This, for example, would be necessary to determine TIS, total isotropic sensitivity. We would need some transparent mode for bit error rate testing or receiver indication of packet error testing. Also, we do need, we have a need here of deactivating of hopping. Regional differences for the 300-220. The bands we've seen beforehand are European-wide harmonized bands, but there are also some bands in the short-range device, in the industrial scientific medical band, that are not Europe-wide harmonized. So if you're going to concentrate on frequencies that are not European-wide harmonized, your product is not to be sold into all those countries. So this is an example of 862 megahertz to 863. You can see that, for example, it's definitely not implemented in Portugal, and we have some other countries which they are implemented here. I think it's Slovenia, I think it's Albania, and somehow I'm missing the country below Ukraine. This is the major band, 868. You can see it's been usable in most places in Europe. We have some smaller limits here in Belarus, in Greece, in the Russian Federation, and also in Sweden. Russian Federation, yeah, it's forbidden to use at airports, and the duty cycle is different. If we're going to 868 to 8686, that one is also not fully allowed in Belarus. Then we have another band, 8687, just for your information. It's not implemented in Ukraine, and it has limited implementation in Belarus. And then we have a very interesting band. That one is going to be a new short-range device band for Europe. Unluckily, this is currently not implemented in all those countries. So as of today, one could use it in Iceland, one could use it in Norway, in England, and in some Eastern European states. I will come to that band later and give you more details about this. There are also some countries in Europe that accept the 915 megahertz. 915 megahertz is interesting-wise the band you need for the US ISM, Industrial Scientific Medical Band. So it is also possible somehow to operate 915 megahertz devices in Europe, but you're not able to operate them in all of Europe. For Germany, I could say that band is not very optimal, as we have GSM Railway, which has been used by Deutsche Bahn at 920 megahertz. So therefore, this band is not allowed. And in 915 to 920 in Germany, we have GSM 900. So German Telekom, Vodafone, or Telefonica would not be very delighted if you operate your devices here in Germany. Okay, short introduction to EMC testing. In general, all EMC testing for devices without radio interface also apply to devices with radio interface. The main difference is that your device still needs to operate in this radio frequency transmission or reception, whatever it is, if whatever conditions has been applied during EMC testing. The overview here shall indicate just few EMC tests that are applied to your device. First one would be ESD, electrostatic discharge for your device. Your device has been, let's say, influenced by harsh voltage potentials between 4 kilovolt and 8 kilovolt, depending whether it's a conducted ESD or air discharge. We have conducted emission and conducted susceptibility. We have an emission testing here. We have interference testing, meaning your device has been put into an environment where harsh electromagnetic fields are applied to the device. We have indirect search for devices that have net power supply. And yeah, okay, this should just be an overview that EMC testing is also required for your device. It's important to know that for emission, we have an exclusion band. So your device operates at 868 megahertz, and it operates here at 14 dBm at the maximum power. If we would stick to standard levels of limits here, given in the standard 301.489-3, then you would hit the limit definitely if your device transmits during the regulatory approval EMC testing. We have so-called exclusion bands. Exclusion bands represent 250% of the used transmit bandwidth. And therefore, the limit is around this amplitude. So no issue with radio devices. You also need to do safety testing. Marius introduced in the very beginning that devices having a radio interface fall under the low voltage directive. The low voltage directive for radio devices has no lower voltage limit. So even if your device has a supply voltage of 0.1 volt, safety testing is required. You could see here which risks are covered. I think these are quite self-explaining, so we could continue. We have a visual testing, connection lines, neutral conductor available if it's net powered, operating instructions, whether it's a protection glass, and so on and so on. We're doing some electrical tests like performance measurements, earthborne testing, isolation, leakage, dielectric strength, cutoff voltage, and battery testing. We're doing some mechanical tests. We have like a test finger test. This is standard pressure to your device being brought as pressure to the outer housing, for example. Let's give you a short outlook on regulatory testing for LoRa devices. As I already said, during the regional differences, we have SRG in 870 megahertz to 875. The duty cycle here is significantly higher with 2.5%, and we have a loud power of 500 milliwatts EIRP. Details can be looked up inside this link here. Links are working also in this presentation. This just summarizes the bands that are allowed according to this standard. As I said, these do not apply for Germany. Where they apply, you will find in the regional differences. Next, we would like to shortly introduce you to market access in USA and Canada, and I would like to hand back to Marius Winzler.
Okay, when we're looking at the market access for the North American market, it is really important to understand that if you want to sell or market a product in the US, the FCC, so the Federal Communication Commission, is giving you the correct information and provides the guidelines how to basically do that. What's really important in this case is that there is no quality EMC, so immunity, there's no product safety. The FCC definitely defines some rules for the private sector telecommunication industry. So, for example, the FCC establishes the technical regulations for transmitters and other equipment to really minimize their potential for causing interference to radio services. And the FCC administrates an authorization program to ensure that the equipment is really reaching the market complies with the technical requirements. When we look at the authorization routes, since November 2017, there are two different routes defined by the FCC. So you have the supplier's declaration of conformity, the so-called SDOC, and the full certification program. The way to go is basically defined by your type of equipment. So you have the unintentional radiators, you have the intentional radiators for unlicensed use, and the intentional radiators for licensed use. That's basically the distinction which authorization route you can go. The question we always get is when it comes to the market access process for the US and Canada is really how to start, and that's the point where I would like to hand over to Markus again.
So some people say that the FCC is a big book of rules. Yeah, not totally wrong. We put in a link here where you could get into, let's say, the basic book of rules, where you could look up your application. We put in the extract here you would need for a LoRa device in the US. Finding the right rule paths to be applied, you can see it in the right part of the foil here. What also proved to be, let's say, fast gaining is to look online at competitors. What have they done? Maybe this also applies to my product. In general, one has to understand the type of device. We put in here unintentional radiators, industrial, scientific, medical, LoRa devices, transmitter unlicensed, and so on. As we're a bit short in time, I would like to go through this a bit faster. Please make sure that once you're going through the FCC certification, that your device meets all FCC requirements. Definitely important. Difference between US and Canada. Maybe most of you know that there's been a change in the past. Some years ago, it was fine. You passed the certification for the US, and you will also be allowed to put your device into Canada. This changed meanwhile. Details can be found on the foil, and I would like to continue. Please.
Okay. That brings us to the point where I would like to shortly highlight how CETECOM can help you. So what we are offering our customers is really the triangle of consulting, testing, and certification. So during our consulting phase, we create the basis for a successful and efficient market access. We offer a broad portfolio of accredited testing services for almost all telecommunication products. And in the end, we handle the regulatory market approval in over 200 countries. And our internal certification bodies provide direct certification in Europe, Japan, Canada, and the US. I can imagine that there are a lot of questions based on the content we just presented. And therefore, I really would like to highlight that if you have any questions regarding the regulatory approval of LoRaWAN or any other radio devices, feel free to get in touch with us. Especially for this event, we created a fast lane support to make sure that your questions are answered directly. So simply contact us at ttbc@cetecom.com. We are definitely looking forward to get in touch with you, get your questions, and try to answer them, that you are definitely aware how to tackle the regulatory approval of your radio devices. But that brings us to the last slide. So thank you very much from our side for your interest. It was a great pleasure to be part of the Things virtual conference and try to bring you the regulatory part of approval of device a little bit nearer and make it clear. As said, please make sure that you send us in any kind of questions. But from CETECOM, again, thank you very much for your interest in our session. This has been Marius Winzler and Markus from CETECOM, and enjoy the rest of the virtual conference.